Hello, everyone, and welcome to our webinar today. My name is Robert Hodges. I'll be presenting. I'm CEO of Altinity. We're going to be talking about building a low-cost, high-performance analytic platform with Kubernetes and open source, and actually building something that can replace proprietary services like Snowflake or BigQuery. So if you came in hoping that you'd find a solution to that question, we're going to be answering that today. Before we get into the webinar, I would just like to make a couple of announcements that will help you enjoy the webinar better. First of all, this is being recorded, as you probably saw when you entered or you heard when I turned it on. So you don't have to take frantic notes. We will post the recording to everybody who's signed up, usually within a few hours of the webinar completing at latest on Friday morning. We will also send the slides. Second thing, we have time for questions. If you have questions as you're going along, you can post them into the chat, or you can use the question and answer box. We can see it, and if it's relevant to the talk, I may just dive in and address it right then and there. Otherwise, we have some time at the end. Let's see. I think those are the main announcements today. Let's get going and have some fun here. So let me make some more detailed introductions. My name is Robert Hodges. Once again, my day job is CEO of Altinity, but I've been working on databases for getting up to 40 years now. And I've been working on Kubernetes since 2018. So very interested in this technology. And particularly the topic we're talking about today is very near and dear to my heart. I'm backed up by a great engineering team. We have 45 people in the company spread out over 17 or 18 countries. And we're heavily engineering. We're database geeks. Taken together, we have centuries of experience in databases and the applications built on them, and particularly analytic applications. That's the core business of Altinity. So we're enterprise providers for ClickHouse, which we'll talk about during this talk. We will also, just so you know about us, we run we built the first cloud service for ClickHouse in Amazon and also in GCP. Azure is on the way. It's been up and running for several years now. We're also the authors of the Altinity stable builds. These are builds of ClickHouse with long-tail maintenance and also certified for production use. And finally, we wrote the Altinity Kubernetes operator for ClickHouse, also known as the ClickHouse operator for short. We use it in our own cloud service, but it is widely used throughout the world in ClickHouse installations. There are tens of thousands of ClickHouse clusters that are managed by that operator. So that's all the introductions. Let's dive in and get to the topic. And what I'd like to do to begin with is just dive in and look at cloud analytic databases and how they work, and also explore some of the trade-offs. So the database I'm going to pick is Snowflake, and it could be BigQuery, it could be Redshift, but Snowflake is a great one to start with. It was and is a pioneering database. It was really the first cloud service, the analytics service that exploited the full capacity of object storage. And in fact, in this architecture picture, you can see that the base layer of storage is object storage. It is, so on Amazon, that would be S3. And so all your data when you're using Snowflake is going to be put into object storage. And then when you actually want to run queries on it, you have to stand up what's called a virtual warehouse. So that's these boxes with the little sort of amber colored or tan colored nodes. Those represent compute nodes. And the idea is that if when you want to do your queries, you'll stand up the virtual data warehouse. It will access the data in storage. It will pull parts of it into cache and enable to run your queries. One of the great things about this architecture is if you're in a business and you have a bunch of data that everybody looks at, you can set up different virtual data warehouses that share the underlying data, but then are completely separate for the purposes of compute. It's a very flexible architecture and has a number of advantages. And then the top layer of the architecture, you have your cloud services. This is the thing that makes this work in cloud, including things like access control, metadata management, which just means remembering where everything is. They have a great query optimizer. We'll talk about that in a second. Full transaction security, you name it. It's a very, very capable service and a really outstanding product. And while I'm singing its praises, let's talk about some of the things that are really excellent about it. It's general purpose. So the thing about Snowflake is it can handle a wide number of applications with very little, without having to change the, without having to do anything really special. It has completely serverless operations. So as far from the point of view of a user, they have, that there are, there are VMs and hosts under there somewhere, but you have no direct connection with them. It just works. It can handle a very large number of tenants with completely different applications. So this is one of the key things that practically part of being general purpose. Widely varying applications will run safely on this architecture without interfering with each other and fulfill their requirements. Another big strength, and this comes no doubt from the Oracle heritage, is they have a very complete implementation of SQL. So full ACID transactions, have a very sophisticated query optimizer, which means that you can pose complex queries with lots of joins, and Snowflake will figure out a reasonably efficient way to do it. It has very good columnar storage. Columnar storage is a standard for data warehouses, and but what's really important here, and where a lot of the innovation is it's completely self-tuning. You don't have to do anything to get high levels of compression and just the right partitioning of your data. Snowflake does it automatically. And finally, it does big table joins. So you can join lots of different tables. You can join very large tables. It may not be fast, but Snowflake will figure out how to do it. Last thing that most people notice is it just has a nice web interface. It has a UI, built-in SQL editing, lots of various management features, so that you can just jump right in without installing any software, get to work. So these are great features, and this is why Snowflake is among the most popular data warehouses out on the internet, if not the most popular one. However, there's some things it doesn't do, and from the perspective of users, these could be important. So, for example, it doesn't keep the data in your account. It's in the cloud, but it's owned by Snowflake. Another thing it doesn't do is it's not really designed to minimize cost. When you're running a SaaS business, for example, or you're running an analytics system that, for example, that is watching crypto, that's a common analytic use case. These are things that run 24/7. Security management systems do the same thing. Snowflake is not really designed for that. As a result, you can get huge bills if you try to do this, and it takes a lot of careful management to ensure they don't go out of bounds. It's not designed to give a stable real-time response. So sometimes there's a lot of, like, if you need a response in 20 milliseconds because you're filling out a page, Snowflake is probably not the database for you. And other things that you can read here, down to the fact that it's completely proprietary and you're locked in. So if you want to go somewhere else, you're going to have a major migration. As a result of this opens up an opportunity to think about a different way of solving problems that does not involve Snowflake. And that's the next part of this talk, which is to think about how you might design an analytics service that gives you the capabilities that you would expect from a product like Snowflake, but does it better for your requirements. So let's just dig in and look at a specific problem. What we're going to focus on, just as an exercise, is building a GDPR compliant replacement for Google Analytics. Many of the people on the call have used it. Google Analytics is one of the classic data warehouse use cases. It allows you to go in and see what's going on your websites. You can do slicing and dicing queries. To make a long story short, you're going to need an analytic platform, and that's shown here in the middle. And it consists of, you'll have data storage and query, so the ability to put the data in, get it back out to answer questions. You'll have things like data pipelines and service integration. So you can think of that as workflows, for example. And you also need to have data visualization and consumption, sort of ways of showing the data and making it accessible. In these systems, you typically have something that's feeding the source data, often very fast. This could be millions or tens of millions of rows per second. And then on the other side, the consumption side, you're going to have facilities for visualizing it for your users. You know, you can think of UIs, APIs to get data, ways to prepare extracts, and then alerting. So the core thing that we're going to focus on is building this basic analytic platform. So when we're coming into this, the first step, as we're going to build the open source, is to scope the requirements. Think about what it is you really need to serve to solve this problem. And if we look back on that list of Snowflake's strengths and weaknesses, you'll see that the Snowflake, many of the things in Snowflake, like being general purpose, don't really count here. They're not part of the requirements. That's why they have an X, because we're only solving one problem. We don't have to solve a bunch of problems. So our platform can be very focused. Now, one of the things that Snowflake does do that we'd like to have is some nice SQL editing capabilities, because we'd like to go work on the system. So that's something we do need. And then what we need, in fact, to solve this effectively is we're going to need to meet all of the requirements that Snowflake does not meet. So ranging from keeping data in our own account to no vendor lock-in. So this is well suited. This right side is actually pretty well suited for open source solutions. So the next thing we want to do is go pick a database. So here's some options that you have that are all licensed Apache 2.0. So they're permissively licensed. You can use them any way you want. And they include OpenSearch, ClickHouse, and Presto. So OpenSearch is based on Lucene. It's great for document search. It has full text indexes. It's very efficient at sifting through large amounts of semi-structured data, for example, JSON, it's often used for log analytics. It has some nice things like Kibana and Logstash that integrate with it. But that's not quite what we're looking for here, because we're trying to do very slicing and dicing queries, and we need very rapid response. Another thing we could look at is Presto. That allows you to, it works on data lakes. It basically does federated query across a bunch of different data sources. It was originally developed to scan very large amounts of data sitting on object storage or similar, or HDFS. That's not quite what we're looking for here, because our data is reasonably structured. And again, we can afford to put it in a proper format. ClickHouse, it turns out, is just the right solution. So it's real-time analytics when the data are structured. So in other words, when they fit nicely into tables, there's a lot of flexibility about what goes in a table, but web analytics is actually the canonical use case for which ClickHouse is developed. So this is a good choice. So just very quickly, for those of you who are not familiar with ClickHouse, this is the database architecture that we'll be working with. So it is kind of, you can imagine it as MySQL. So it's an open source database. Talks SQL, runs anywhere, but it's on steroids. It's designed to do analytics. So it has a number of important features, ranging from the server nodes, which do very efficient vectorized and parallel query. They also support sharding, replication, and distributed queries. So the ability to blast a query out and have a bunch of servers work on it simultaneously. They store data in columnar form, extremely efficient compression. In fact, just as efficient as Snowflake, but you have to tune it a little bit to get there. And then they can also read and write data efficiently to object storage. So we sometimes call this tiered storage, where you'll keep your hot data in the block storage, and then you'll have older data out on S3. ClickHouse also includes Zookeeper. So in order for replication to work between clusters and to do some of the other functions necessary for clusters to be maintained, Zookeeper is there for consensus. It keeps a list, for example, of all the table parts that need to be replicated between nodes. So this is the architecture that we're going to be building on. So this brings us to the next step, which is to lay out platform design. So we have ClickHouse, so that's our analytic database. We've got Zookeeper, that's there for consensus. We would like to have good monitoring for this so we can keep an eye on what it's doing and also help us diagnose things that are going on inside the database. For that, we're going to have Prometheus, which is a standard monitoring solution on Kubernetes. We're going to use Grafana to visualize the monitoring data. And then finally, to make life easier for our developers, we're going to include Cloud Beaver. So Cloud Beaver is a cloud version, a containerized version of dbeaver, which is a very popular SQL editing tool that we use constantly. So that's the basic design that we're going to want to have in the stack. And so the next step is to think about how to turn this into reality. So this is where we get into Kubernetes and Argo CD and the actual implementation. Let me just start by introducing Kubernetes, because I'm not assuming that everybody on this call knows what it is. So basically what Kubernetes does is it is a system for orchestrating container-based applications. And what that means is you can have a pool of machines, and if you have an application which can be, for example, defined as being a set of one or more Docker containers that contain the software, you can put it on Kubernetes and Kubernetes will run it for you. Here's a really simple example. So let's say that we have of how Kubernetes works. You have the logical application design, and that would be a ClickHouse server, which runs great in containers, and it's talking to some block storage. So this is your typical server. What we would do is we would represent that in Kubernetes as a series of resources. And these have special names, but they're basically resources that are designed for describing distributed systems. So we have a stateful set. That is a type of resource that has a standard name and manages storage. There's a pod, which is the actual part of which is actually the compute part, the processes that need to execute. There's the persistent volume claim, which is a request to Kubernetes to allocate storage of a particular type or meeting a particular SLA. And then there's the actual persistent volume, which is a resource that represents that storage. Kubernetes now will map this, will take these resources, and it will look at the outside, the physical infrastructure, and it will actually go ahead and spin these up and run them. So in the end, somewhere out in the Kubernetes cluster, you get a process running on the host, that's the ClickHouse server, and it has a mount to, in this case, Amazon EBS storage. This is what Kubernetes does. And it's kind of trivial here. You could say, hey, I could just spin up a VM, but actually real systems like the stack we're developing are complex. The nice thing about Kubernetes is it will manage a lot of containers with a lot of different resources and do so efficiently. So when we go to Kubernetes, then we're going to have to think about the logical design. All of the elements that we have are included, are available as Docker containers. So that's great. There's also one extra thing that we're going to add, which is the Altinity operator for ClickHouse. So in order to make ClickHouse run properly or to manage it, we're going to need a thing called an operator, which is a special kind of controller in Kubernetes. And what it does is it creates new types of resources. In this particular case, we create a resource for ClickHouse databases. So what we're going to have to do is we're going to build our stack. We need to find the Docker images for all of these. But most important, what we're going to need to do is figure out how to install these all in a consistent way. So this is a big problem in Kubernetes, that everybody does things differently. So for example, the ClickHouse uses the operator, so you'll need to have the operator, and then you'll need to provide a manifest which describes what's going on. Cloud Beaver, you can install it through a manifest. Prometheus has Helm charts. The Altinity operator has Helm charts, and they all do this a little bit differently. So the first problem that we get in standing up this stack is, okay, how do we paper over all these differences and make this stuff work? So the answer is, and actually there's one more thing we'd like to do. We would like to have, since we're building what amounts to a cloud native stack, which is to say it's running on Kubernetes, it's based on containers. One of the really important things we want to do is we also want to define this infrastructure setting that we're setting up we want to define it as code and store it in GitHub or GitLab, as the case may be. But the point is that it's stored in a source control system, and then we want to have a way of taking the current definition of the system and turning it into something that runs on Kubernetes. So these are two problems we have, is to take this GitHub definition of the system and turn it into something that works on Kubernetes, taking into account that each of these components that we mentioned is going to get installed in a different and often a radically different way. So the answer for that is something called Argo CD. It's not the only answer, but it's become quite popular because it does this well. What Argo CD does is, first of all, it knows how to read data from GitHub automatically. Second of all, it has the ability to support various kinds of definitions of applications or services in ClickHouse, or excuse me, in Kubernetes. These include things like defining an application through a manifest, using something called Customize, which is a project from the Cloud Native Computing Foundation that can take these resource definitions and actually tweak them based on the environment you're going to, or otherwise parameterize them. And Argo CD also supports Helm charts, another super popular way of installing services on Kubernetes. And so basically they pass through Argo CD, it looks at them, and then it will map them to resource definitions. It will, either run appropriate procedures or otherwise transform them. It'll then stick them out on the Kubernetes cluster where you want to go. So that's basically what Argo CD does. When you actually look at it on the ground level, here's a more complicated picture, but the idea here is this person on the left is a developer. They define the application in a GitHub project. They have application definitions, which can be just folders or directories. Those Argo CD runs inside Kubernetes itself, so it's a service you install in Kubernetes. You can tell it where the applications are, and then what it'll do is it'll pull them down. It has a repository service and then a thing called an application controller. It keeps track of, hey, here's the application in GitHub. Do I want to now sync that content, to what's going on in Kubernetes? And it takes care of, basically takes care of keeping these things in sync. And then, of course, it has an API which give us the ability to issue commands to define the applications. In other words, tell where they are, to synchronize them with Kubernetes, and then get rid of them when we're tired of them. So that's gets us to the final thing, which is the basic life cycle, which is that when we're installing these services, we will create them as an application. And really what this says is tell Argo CD, where is this thing? And then, and then synchronize it to Kubernetes. You may do that multiple times, and then eventually you may remove it. So let's go ahead and try this. We're going to go to the demo because it's more interesting to look at. Let's get this out of this. So one of the things to start out with that this what we're going to do with this demo is it's based on a project that is published on the Altinity GitHub, and it's called Argo CD Examples ClickHouse. So all of this code here you can repeat yourself, and you can just come out and clone this afterwards and repeat what I've done here yourself. It's fairly straightforward to do. So there are instructions for this, and we won't spend too much time on that because you'll see examples of it. Let's go look at a typical app. So I'm going to pick the ClickHouse operator because I'm going to walk through this entire life cycle. So here's the app. It uses a Helm chart. So we have a definition of the Helm chart. That's something we store out there. Another thing we do is if that Helm chart, went too far. If it has values, we can stick them in values.yaml. I'm not going to change anything. I'm just going to take the defaults. So that will be fine. And then it has some documentation to tell you what to do. And this documentation tells us something useful here, which is, here's a sample command to actually get this thing defined in in Argo CD. So we don't really have to think about it ourselves. Let's go ahead and execute that command. So, I have a namespace here in Kubernetes where all this stuff is going to go. So I'm watching this namespace, and as we execute these commands, we can see how things get stand up and appear in Kubernetes. So let's go ahead and, oops, that's a looks like we got the wrong thing. Just a second, let me get this copied properly. There's a little bit of little weird sometimes to go between. All right, there we go. So what we're going to do is we've just told Argo CD, hey, we've got a new application. Here's where to find it on. Here's how to find the GitHub project, and then the path is here's the directory that it's in that project. And once we've done that, we can then ask Argo CD, hey, what what applications do I have out here? So we can just list them. There we go. If we can type, and we see we have one application in Argo CD, and it says out of sync, which means that Argo CD knows about it, but it also knows that this application has not been synchronized with state in our target ClickHouse cluster. And you can see the destination, this destination server, that tells it where to point to actually set this thing up. Let's go ahead and synchronize that. So you see a bunch of stuff flowing out here, and what is happening right now is Argo CD is applying that Helm chart to Kubernetes. And if we go back to this list where we're showing things in the namespace, voila, you see that this application is now up and running. So all I had to do was issue just a couple of commands here, and I got the application. And for me as a user at this point, say I'm an SRE, I don't have to know how I did it. So I don't have to know that it was a Helm chart. It's now just up and running. Let's go ahead and, since we've synchronized it, let's go ahead and clean it off. So we're going to go ahead and make it go away. And this completes the life cycle. Of course, you wouldn't, in a production system, you wouldn't do this, but you might do this quite a bit in development. So we'll go ahead and do a delete. And we're going to say, yes, we'll delete all its resources. And if we go back over here, it's gone. So it's that simple. This now will work for every single service. This same approach will work for every single service that we have in our, in our stack. So rather than type these commands in, let's just run a script. And I want to be clear, if you've used Argo CD before, there are other ways to do this. I'm just doing it explicitly because you can see what's happening. I'm now going to run a command which is actually going to go ahead and create this stack. So this will run a bunch of create commands. And one of the reasons I'm doing this is that it allows me to ensure that things come up in the right order. We'll talk a little bit about dependency management, but I'm just going to run this script. And basically what it's going to do is create each of these applications, and then it's going to sync them. So let's go ahead and let that run. So it's giving me a chance to get out. And so it's going ahead and creating created the applications. It's now synchronizing them. So if we go to our, now what I'm doing here is I'm actually going to a bigger display, which allows me to see all the containers that are coming up. But basically this entire stack is now being built inside this namespace. So I'm going to give this a second or two to come up, and then we'll go ahead and connect to it. Let's see, I think we've got most of our services here. This looks like a good time to go ahead and begin. I need to give it one more, actually one more second, because I'm going to go ahead. In fact, what I'll do is we'll give this a second to fully bake, and let's talk about some key issues here. So when you're developing these, let's go ahead and bring up the slides. Wrong button. So when you're developing these, you need to pay attention to dependencies. As I said, this is one of the things in Argo CD that you have to think about very carefully. Argo CD has features to help with this, but sometimes the simplest way is just to run a script. So my services have the dependencies shown by the arrows here. So for example, the ClickHouse operator needs to be up before ClickHouse. It's nice if Prometheus is there, although not necessary. And then another thing we have to think about is exposing these services because we want to work with them. In my particular case, so you can forward them, you can do peering, sort of add them to your network, or you can use a VPN. These are all sort of obvious ways that you can connect this Kubernetes cluster, but the point is to give them a way of connecting to your applications so that you can play around with them and see them in your browser. So these are, that's what's going on there. So now by this time, the stack should be fully baked. Yep, we see ClickHouse. There's ClickHouse at the top. We see services for everything. Let's go ahead and begin to forward the. Just one second here. All right, I'm going to go ahead and do forwards. I'm doing it in another window. But what you'll see is, let's go ahead and, for those of you who are Kubernetes experts, we've now got a bunch of forwards, which are basically exposing ports. I'm going to do one more thing, which is this is happening out in Amazon. My browser doesn't live in Amazon. It lives on my laptop. So I'm also going to open up SSH tunnels to these. So I'm going to go and do that again in a separate window. I'm now tunneled through to all of those endpoints from this laptop. So let's go have a look and actually talk to these applications. So the first one we're going to talk to is ClickHouse. So you can see here I'm tunneled through and it's showing up at port 8123. If I go ahead and run this, first time I get it, it's kind of a weird behavior. The first time you get it, it doesn't know what's going on. Run it again though, and I'm actually starting to see data coming out of ClickHouse. So this ClickHouse is fully set up. It's running. I can select the number of rows in the system query log. It's only 3. Another thing that I can do is I can actually, this is a pretty primitive SQL editor. I've got a much better one that's available with dbeaver. Let me just go refresh this and I'll have to log in. So this is, I had configured this previously, but I've got I'm going to go ahead and log in. So, and once I'm logged in here, I will go ahead and open this up. And so I'm going to open up a connection to ClickHouse. One of the things I did in my stack is I defined a root user. Oops. And I'm going to go ahead and use that account. And hopefully let's save the credentials so we don't lose them. Okay, bang, we're in. And let's go ahead and open a SQL editor for this. And let's just see if this is alive. Okay, so we're talking to, again, using a full-featured SQL editor. So talking to our, that's actually talking to ClickHouse, knows all the data types. If I had tables, it would show them, so on and so forth. And so basically, I can now begin development of schema on this system. The final thing is, how about some metrics? So what I did was I stood up went ahead and stood up the monitoring in Grafana. This is something I did on a previous run, so you don't have to see me load load this continuously, but you can, or go through the steps, but you can see some of the queries that I actually executed popping up on this monitoring. It's actually bouncing back and forth between a couple of different hosts, but select star from system.querylog, that was something that I set up. So what this has done is basically by running one script, I'm able to set up this entire stack. Moreover, if I want to change things, like want to change the amount of storage that I'm using, let's just take a specific example. So if I want to alter the behavior of the system, I can just go to the appropriate place here. And I can make changes. And I'll just show you what it does. But so for example, if I wanted to add more replicas or more shards, I would simply go into this resource, which defines the ClickHouse server, and I would make this change. And you can see that I've modified a file in Git. I could say Git, I'm not going to do this because I don't want to mess it up, but I can now say Git add demo.yaml, Git commit -m, and if I go ahead and commit this and then push it up to GitHub, I can then sync it and the value will be applied to my stack. This is basic. This is GitOps in operation. Okay, so that is the demo. Let's go back and look at some additional issues. So go ahead and restart the slideshow. So we talked about the sort of dependency management and connecting to applications. Just as you look at Argo CD, there's definitely some these systems are inherently complex. Argo CD allows you to manage it, but it doesn't necessarily make the complexity less. It's just that it's safely stored in GitHub where you don't have to look at it all the time. So some of the really great things about Argo CD is, well, first and foremost, it enables infrastructure as code. So your configuration lives in Git. You don't have a problem remembering what it was you did to deploy the system, because that's where it came from in the first place. If you want to change it, you can just make a change and resynchronize. Another very powerful capability is that you can map configurations to multiple environments. So you could have like a dev environment, a stable environment, like a staging environment and a prod environment, or you can do blue and green deployments. That's where you have two production versions of the system, one that's your current prod version, another one that's maybe post-upgrade. You run them in parallel and then you switch over. This is stuff that Argo CD enables in a big way. It's super adaptable. You can usually get, I've tried a bunch of different things over the last couple of weeks, and you can basically get just about anything to install, as long as you can somehow get it as a Helm chart. You can make your own manifests. You can, as long as it's containerized, you can basically get it to install. And another really cool feature, which is kind of implicit in the ones above, is you can then evolve the components or exchange components easily and evolve the stack. So that's really important, because the hardest part, actually, in many ways, of building these systems is not putting them up the first time. Everybody's focused on that and it gets done. It's changing it later on, and changing, switching components without wrecking everything that you've done. Some of the weaknesses are things that you need to take into consideration. One is you do need to understand Kubernetes. To use Argo CD effectively, you sometimes have to connect the dots a little bit about why it's doing things in a certain way. If you understand Kubernetes, it's very straightforward. Not everything is mature. Argo CD is a fairly new project. It's very powerful. It's evolving nicely, but there are things like, for example, there's a feature called applications that can group these or the application sets that can group apps together. It's still a work in progress. The GitOps automation, when you enable it fully, it is complex. So you're using webhooks, you're using various kinds of notifications coming out of Argo CD. If you go in fully, it will take you a while to get it set up, and you'll have to spend some time on it. And finally, it doesn't handle deployment outside of Kubernetes. For that, you need Terraform, you need Ansible, or whatever your favorite form of automation is to do things like setup, EKS or GKE. So these are all things that you'll need to think about. But on balance, this is a really powerful tool to build these stacks, which then allow you to have your own analytic processing. So let's talk about three final issues that are between, once you set this up and you prototyped it and you like it, things that are between you and getting a production analytics stack out and running. So in no particular order, one really important thing that you want to think about hard is buy versus build. So you're building the stack, and right, you're not using Snowflake, but it still makes sense to manage stuff. So you can always you can always lean on people. So for example, in the systems that we see, so a lot of our users are building systems this way. If they're running in the cloud, they almost always, and they're running on, say, Kubernetes and Amazon, they'll use EKS. We use it ourselves. The reason is it's cheap. It's really not very expensive to run. You pay a small amount for the management costs, but basically you're just paying for the VMs that run on your Kubernetes cluster. You would have done that anyway. Same thing on GKE. So virtually everybody uses this. They don't typically run Kubernetes from scratch. At the other end, you have your applications, which people almost never outsource because that's your basic value. So you control that. That's going to be running inside Kubernetes and actually can be deployed using this same mechanism. The part in the middle is where you get the interesting choices. And just to pick one, you can run ClickHouse yourself, or you could use Altinity.cloud or one of the other cloud vendors. So Altinity.cloud, as I mentioned, is a cloud for ClickHouse, and it has kind of an interesting property, which is one of the things that this whole Kubernetes architecture enables, which is that you can actually manage this. You can actually manage ClickHouse clusters in your own Kubernetes. Here's how it works. So we have the Altinity Cloud Manager, and most of our customers, because they started early on, are actually running in our cloud account, just like Snowflake. So, and what we do is we stand up for each of our customers. They have one or more environments. Those are dedicated Kubernetes clusters, which we stand up for them, and we run ClickHouse there. And then, take care of security, take care of, management, upgrades of Kubernetes, all that sort of stuff. But what you can also do is, because we run on Kubernetes, there's another thing that we call Altinity.cloud Anywhere, which basically allows you to register your own Kubernetes clusters, and then you go and you install something called the Altinity Cloud Connector, and at that point, we can manage the Kubernetes, the ClickHouse clusters for you. More importantly, is we have full visibility into it, and so if you have problems, we can often deal with them proactively before you even see them. Like you're running out of storage, for example, we can address that for you, which means that this part of the stack, which is kind of complex to manage, is just taken care of by somebody else. But you're still meeting your other requirements, which is to, for example, have the data local, be able to control the costs of the resources, and being able to avoid vendor lock-in. Because what we are managing is completely open source, and you can just disconnect from us at any time. So that build versus buy is one of the issues. The second one is security. And this is something that requires thought. And I'm just going to give you a simple example in Kubernetes: connectivity. So in-flight protection of data. There are just there's standard ways to deal with this. The trick is just to make sure you're using them effectively. So for example, making sure that your client applications are always using TLS encryption with strong ciphers, or doing things like IP whitelisting, all the way to ensuring that you use standard Kubernetes like features like secrets to pass around data safely so that they're not exposed as things like passwords are moving around in the environment. These are things that you need to do. Luckily, most of the services have thought about this at some level, and I'll give you an example from our ClickHouse operator. So, some of the things that you can do in the ClickHouse operator is you can, for example, by correctly annotating things, you can make sure that the load balancer doesn't open up a public port. That's a classic problem with EKS. This will ensure that it's only locally routed. Other things you can do is and it's just another example, you can have the ClickHouse installation default to secure ports only, and you basically shut down anything else that is not being used. So you'll want to find operators are very good about this. They're like this the one of the best ways to manage databases in particular. So you want to look for one that has security features and a hardening guide, which will help you do this. The final thing is just the other tasks required to deploy the analytics stack. In some ways, setting up the prototype, that's pretty easy to do. But what does your stack look like? What other services do you need? You could need Airflow. You could need Spark. These are all things that you'd need to pop them in. They can be installed in the same way and managed the same way. Then getting the automation fully built out, adding your hooks so that, for example, adding a webhook so that if you publish something in a prod, in a production branch on GitHub, Argo CD will automatically wake up and apply the changes. So you can use a webhook for that. Other standard things for databases include capacity planning, performance scaling, backup monitoring. These are all issues that that you have to get through before you can deploy something. I will say that one of the great things about Kubernetes is it allows you to iterate through a lot of different combinations of VM types, storage types. And with Argo CD, you can basically just, sort of wipe the applications out, bring them back, with a new configuration and new storage, and off you go. So, and then of course you have to build your apps. So, but you had that problem anyway. So these are three things that you'll need to do to get finished. But at that point, you've built a replacement for Snowflake. So, and we've seen this happen so many times that we know this is the way that many people approach these problems. The key here is basically to keep the problem simple. So focus on the application you're building. Don't try to be general purpose. As long as you do that, then you can really build something great. So we're approaching the end of the talk. We have some time for questions. So you might want to queue those up. Here's just some tips for building your own analytics platform. So the first thing is to know you can, and that you have the option. If, for example, you want to own your own data, you can build it. So for specific, the key here is that you're going to build something better than Snowflake on balance, provided you focus on a specific problem. If you want to build a general service, well, it's going to be tough to beat Snowflake. It's really good. And it, as I say, it can support a wide range of applications, and it makes it very convenient for people to do that. So you want to have a specific problem, and you want to keep it as small as possible. So don't add more requirements that you don't need. So for example, on security, there are ways by protecting the overall environment, you can make the security within Kubernetes, of course, much simpler. As long as the stack you're building is not end user facing, that simplifies problems like security, like the number of things you have to manage. Kubernetes, if you're going to build this kind of platform, it is the stack to use. There really isn't an alternative at this point that's general purpose, portable, support scaling up, scaling down. It has all the parts that you need. So we definitely strongly recommend this for this type of platform. And then Argo CD is a key to getting GitOps to work. So mapping these definitions flexibly for the different services, mapping them flexibly through to an actual, from GitHub to an actual application running in Kubernetes. Obviously, this does require expertise and careful design. One thing with the open source is you own the problem. I mean, the stack is yours. You can see what it's doing. You have full control, but it also means you need to understand what you're doing or partner with people who do. And that's typically what we see is people will often outsource the complicated parts. So for example, understanding the details of how ClickHouse works, that makes sense to outsource to somebody else, but you can keep the rest yourself. And then finally, Argo CD, as we've seen, doesn't handle anything outside of Kubernetes. So just how do you get started? All you have to do is go look for this application and clone it and read the directions. It's a pretty fresh project. You may run into a few bumps. Feel free to log issues or contact us on Slack. Just in terms of to give people credit, here are the projects that went into this stack. Obviously, Argo CD, we wouldn't be having this talk without it. We have a number of projects that are related or relevant here, including these examples I just showed you, the Kubernetes operator, as well as the Altinity stable builds, which I was using for this demo. And then there are other components. Of course, there's the upstream ClickHouse, and then Prometheus, Grafana, and Cloud Beaver, all key components. And we recommend all of these wholeheartedly. They're great. So that's it. I hope this has been interesting. We have a few minutes left, so we can address questions if you'd like to, ask questions about building your own stacks or anything you've seen in this talk. I'd be happy to answer those now. And you can go ahead and just post those into the chat or into the question and answer. Is anybody here? I have a question for you. Is anybody here building a stack like this? Just curious. Here's a great one. Thank you, Errol. What's the best way to include S3 as a data store? Parquet or ClickHouse on S3 format? The answer is yes. That's a great question, and I think a really important one. Let's go back to this is the reason we had a picture of the ClickHouse storage. Let's get back there. Yeah, so the way that it kind of depends on what you're doing. So ClickHouse supports something called tiered storage, where you can keep a fraction of your data in block storage, as I'm showing here, and then keep the long tail in S3. And you'll set up what are called storage policies, which you can then apply when you build a table. So like you have an events table, you'll say, hey, use the like the hot cold storage policy, and then what you can define in when you define the table is you can explicitly tell through the SQL definition of the table at what point do you want the data to move between tiers. So these are called TTL moves, and so that model is supported. The good thing about that is that your applications don't have to make a distinction between whether the data is stored in the block storage versus whether the data is in S3. You can just do a select and it will happen. If it goes to S3, it could be a lot slower, but depending on how big a scan you're doing, but that's the only difference you'll see. The other way you can do this is you can actually take the data out of, move the data, archive the data from the block storage and put it into something like Parquet and S3. And then ClickHouse has what are called table functions that allow you to read that Parquet as if it were a table. And in fact, there is I believe a Parquet table type, but I haven't used it very much. But the thing the distinction there, and this is it has a plus and a minus. The plus is that once you push it into that archive storage, basically in your data lake, other applications can read it without bothering ClickHouse. So for example, you can light up pandas and go read these things. You can feed it into something like PyTorch to do ML on it. So that's an advantage. The disadvantage is that your analytic applications inside ClickHouse will most likely need to know that they're going to a different table because its properties will be different. Moreover, there are limitations on things like how do you delete data out of Parquet? That doesn't happen automatically. Whereas if you delete data from a ClickHouse table, ClickHouse will take care of removing it in good time. So so what you can do then is, if you're going to use, to complete this, if you're going to use the, for example, the tiered storage, you just set up the storage policies and you can basically include them in the definition of the ClickHouse cluster that you're building. You just put it in GitHub and then you sync it using Argo CD, as we just saw. Great. So I see somebody here is building something similar, but using Apache Pinot instead of ClickHouse. That's another, actually another database out there is Druid. Druid, Pinot, and ClickHouse occupy a similar space. So most of what we've described here, you could do with Pinot as well. And it's a matter of taste. There's some trade-offs in the systems. Yeah. Okay. What's the difference between ClickHouse server built by ClickHouse.com and Altinity? Which is better suited for the operator? The answer is yes. We can support both of them, and this is a really, what's the real difference is, what is it that you get with the stable builds, and versus, and let's just run something up here. I think I've got these. Oh, I don't have the. If you go to the stable builds, which are referred to here, here, let me just show you this. Let's go to the docs. There's basically one table that explains it all. So these are Altinity stable builds. So we release on the LTS. We're tied to the ClickHouse LTS. They're long-term support releases. They come out twice a year. And what we do is we use those as a basis for ClickHouse builds that are, certified for production use, which means, hey, no nasty bugs that we know of, no things that'll corrupt your data. Second, they're supported for 3 years. And so if you're an Altinity customer, for example, and you want to get bug fixes, this is the way to do it, because you may, for example, run the build for 2 years. We have customers that run it for actually far longer than that. And so the stable build is around. If you run into a bug, we will also push small features back. Like if a new feature comes out in 2023.4 in a community, in basically one of the monthly builds, and it's really valuable, we can actually port it back into the stable builds. The part about them being production certified is more important than you might think. ClickHouse has this model that it evolves, it seeks to evolve very quickly, but what that always means universally, and especially in databases, is it means that the builds in the head revisions are unstable. So what we find is that you usually have to wait 3 to 4 months before an LTS build becomes suitable for production use. That's basically been the long bar for us on testing. We monitor the usage really carefully to find out what's what the state is, and then we do detailed release notes, including all the stuff you have to look out for when you upgrade. So that's the difference. Let's see. It is okay. There's a question here. Is it compatible? It is compatible with is this a question with a Kubernetes installation on premise? The things that we showed you here, assuming that the question is yes, absolutely. Can Altinity ClickHouse Stack be implemented on premise VMs? Yes. Absolutely. Kubernetes, and this is one of the things that I was thinking of doing this, but it seemed like a bridge too far in the demo. I could take this thing and point it to Minikube and just bring it up on a computer sitting on my desktop. But there was enough, I think this talk was complicated enough. So the answer is absolutely. The thing that you don't get as easily in-house is you don't get the auto scaling, which is a really great feature of things like EKS and GKE. You can basically tap into, sort of set up a provisioner, which will just spin up VMs whenever you need to add capacity. But other than that, everything should be the same, and it will work fine. FIPS, there's a question about FIPS compliant. We do it. So that's another thing that is that for these builds, we have FIPS compatible versions. that we have a blog article on that. Check out just go to the Altinity blog and look up FIPS. You'll find that. Those builds are available open source. We also support them for people who are going into like PCI DSS and FedRAMP environments. We are at time. So in fact, I have to go to a meeting to talk about FedRAMP. Thank you very much for your attendance. I hope this is useful. If you would like to talk to us further, it's easy to find us. We are, just come to altinity.com. You can find links to join our Slack channel. You can contact us, and we're pretty easy to reach. You can spin up trials. It's all available and easy to use. And if you'd like to talk further about this, about this stack that I've shown you, this modern analytic stack based on GitOps, we'd love to talk to you. So thank you very much for attending and have a wonderful day. Bye-bye, everybody.